What you see is the first image of a black hole that was released in 2019. And this is a picture that was released a few days ago from Galaxy Center black hole of our own galaxy, meaning the Milky Way. It may be not as attractive as hundreds of pictures we see every day. But consider these black holes, because of their nature, are almost invisible. Gravitational pull of the black holes is so strong that even light cannot escape from them. And to observe, we need that the light reflects from the desired object to arise, so we can observe it. Therefore, we can compare observing a black hole to observing a fully black sheet in the darkness. The existence of black holes could be understood from their gravitational effects. Some black holes have limited radiations, but this does not mean observing them. What causes to capture images of a black hole are the materials around the black hole. Because of rotation and motion, these materials heat and start radiating. Just like when we heat a metal bar on fire and the bar turns red after heating and radiates light. This light was produced somewhere out of the black hole event horizon, so it can get away from the black hole. To capture images from the nearest black holes, we should have a telescope that can observe a cookie from Earth that is on the moon. There is no unified telescope on Earth that has such a power, and you should create a telescope as big as Earth. Which is impossible. So scientists and engineers have created a universal network of 8 radio telescopes all over the Earth, which is known as Event Horizon Telescope. Now let's go for observation. First, there's a lot of dust and gas between us and our galactic center, so we can't observe the black hole from 25,000 light years of distance using visible light. The spectrum that our eye is sensitive to it. Instead, we should observe the black hole using radio waves. All of these telescopes simultaneously observe the galactic center, and it should record the signal that each telescope receives in its location with the exact time. By Earth's rotation, telescope can record more pieces of the black hole, and by combining all the data, they can provide a good image of the target. This method of imaging is like a piano that its keys aren't complete, and we want to perform a song. Our brain can fill the gap to identify the song. But scientists face another important challenge. The materials around the black hole move so fast that can change the look of the black hole each minute. This means that the photography subject changes faster than the required time to capture its image. To overcome this challenge, they created computational imaging algorithms that allows us to capture images of the black hole with incomplete data. These algorithms fill the missing information using different methods, and intelligently the EHT team or the Event Horizon Telescope produced thousands of images using different methods. Each one of these images is a bit different, but they're not the same and are consistent with the EHT data. They realized that they can categorize their stored images based on similar visual features into 4 categories. By using advanced algorithms and supercomputers, they combined images, and the final image of the black hole was achieved. They made the impossible possible. We saw the image of something that affected our lives from far away. We're all rotating around this black hole. Isn't it interesting?